Hello, good day friends. You are welcome back to another interesting math question. We are to calculate the area of this blue triangle. We can see this side and this side are congruent. This quadrilateral is a square-shaped quadrilateral. We have the length of this segment to be 12 meters and this is 16 meters in length. So how can we solve this? Well, it is very simple. The formula for calculating the area of a triangle is half base times height. And we can see this triangle has two of its sides to be congruent. That makes it an isosceles triangle. Since this side and this side are the congruent sides, this side will be the base. The height will be a line perpendicular to the base to this vertex here. The altitude of an isosceles triangle we know, if drawn from the unique side, it will bisect it. So this side here will be bisected. That is, this segment and this are congruent. So if we let this be A, this must also be A. This height, let's assume its length to be B. So base equal to A plus A, which is 2A, and height equal to B. Substitute here. Now area of blue equal to 1/2 times 2A times B. 1/2 times 2A is A. A times B is AB. So blue area equal to AB. Now what are the values of A and B? We don't know. But if you recall, this quadrilateral is a square-shaped quadrilateral. And we can see this line here is connecting two opposite vertices of it. That makes it a diagonal of the square. And we know the diagonal of a square is at 45 degrees angle with all the sides. That is, this diagonal is at 45 degrees angle with this side, this, and this side. So this angle, this, and this are 45 degrees each. Now look at this triangle. We have the sides of this angle to be 45 degrees. And this is a right angle. Based on the rule that the summation of angles in a triangle is 180 degrees. This must be 180 degrees minus 90 degrees minus 45 degrees, which is 45 degrees. Now since this angle and this angle are congruent, that makes the triangle an isosceles right angle triangle. The perpendicular sides of an isosceles right angle triangle are equal. So since this is B, this must also be B in length. We have this segment to be A. Therefore, this must be B minus A. Now since this triangle is a right angle triangle, we can use the Pythagorean theorem. The Pythagorean theorem states that the square of the length of the hypotenuse of a right angle triangle is equal to the sum of the squares of the length of the two other sides. The hypotenuse is the side facing the right angle, which is this side here. So since this segment is 12 meters, if we assume this segment to be C, hypotenuse equal to 12 plus C. Now by Pythagoras, the square of this must be equal to the sum of the squares of this B and this B. So 12 plus C all squared equal to B squared plus B squared. B squared plus B squared is 2B squared. So 12 plus C all squared equal to 2B squared. Take the square root of both sides. Here square cancels square root, while here square root of 2B squared is root 2 times square root of B squared. Square root of B squared is B. Root 2 times B is B root 2. So 12 plus C equal to B root 2. Subtract 12 from both sides. Here 12 minus 12 is 0. So C equal to B root 2 minus 12. We keep it aside. come here and draw a line parallel to this line here from this vertex to this line. We know this angle is a right angle because it is the angle of a square. So therefore, this will also be a right angle. Now if we look at this quadrilateral, since 3 of its angles are right angles, we know definitely the fourth one will be a right angle. That makes the quadrilateral a rectangle. Opposite sides of a rectangle are equal. That is, this side and this side are congruent, and similarly this side and this are also congruent. So since this is B, this must also be B, and similarly since this side has its length to be A, this must also be A. Now look at this triangle. This angle is a right angle and this is 45 degrees. Therefore, this will be 180 degrees minus 90 degrees minus 45 degrees, which is 45 degrees. That makes the triangle an isosceles right angle triangle. The perpendicular sides of an isosceles right angle triangle are congruent. So this side and this are congruent. Now since this is A, this must also be A. If we use the Pythagorean theorem on the triangle, this is the hypotenuse. The square of its length must be equal to the sum of the squares of the length of this side and this side. So 16 squared equal to A squared plus A squared. A squared plus A squared is 2A squared. Take the square root of both sides. Here square root of 16 squared is 16, while here square root of 2A squared is root 2 times square root of A squared. Square root of A squared is A. Root 2 times A is A root 2. So 16 equal to A root 2. Multiply both sides by root 2. Here 16 times root 2 is 16 root 2. While here A root 2 times root 2 is A times root 2 times root 2. Root 2 times root 2 is 2. A times 2 is 2A. So 16 root 2 equal to 2A. Therefore, 2A equal to 16 root 2. Divide both sides by 2. Here 2 cancels 2. While here 16 root 2 divided by 2 is 8 root 2. So A equal to 8 root 2. We come here, substitute A equal to 8 root 2. So area of blue equal to 8 root 2 times B. 8 root 2 times B is 8B root 2. Now if you recall, this quadrilateral is a square-shaped quadrilateral. We know all the sides of a square are equal in length. That is, this side, this, and this are equal. So since this side has its length to be the sum of this A and this B, this side, this, and this must also be A plus B. Now another property of a square is that opposite sides are parallel. That is, this side and this side are parallel. And we can see this line is intersecting both. That means this angle and this will be alternate equal angles. Call them E. We can see this angle and this angle are also formed by two straight lines intersecting at a point. That makes them vertically opposite angles. Vertically opposite angles we know are equal. So if you assume the size of this angle to be O, this must also be O. Now look at this triangle. Its angles are O, 45 degrees, and E. Similarly, this triangle also has its angle to be O, E, and 45 degrees. That means they are similar triangles. So taking the ratio of their sides, this side facing angle E divided by this side facing angle O must be equal with this side also facing angle E divided by this side facing angle O. So 12 over b minus a equal to c plus 16 over a plus b. We'll recall here a equal to 8 root 2. Substitute here. And here also c equal to b root 2 minus 12. Replace this c with b root 2 minus 12. So 12 over b minus 8 root 2 equal to b root 2 minus 12 plus 16 all over 8 root 2 plus b. Here minus 12 plus 16 is 4. So 12 over b minus 8 root 2 equal to b root 2 plus 4 all over b plus 8 root 2. Cross multiply. Now 12 times b plus 8 root 2 equal to b minus 8 root 2 times b root 2 plus 4. 12 times b plus 8 root 2 is 12b plus 12 times 8 root 2, which is 96 root 2. Here b minus 8 root 2 times b root 2 plus 4 is b times b root 2 plus 4 minus 8 root 2 times b root 2 plus 4. B times b root 2 plus 4 is b squared root 2 plus 4b, while here minus 8 root 2 times b root 2 plus 4 is minus 16b minus 32 root 2. So 12b plus 96 root 2 equal to b squared root 2 plus 4b minus 16b minus 32 root 2. Plus 4b minus 16b is minus 12b. Now bring all these to the right. Minus 12b minus 12b is minus 24b. Minus 32 root 2 minus 96 root 2 is minus 128 root 2. So 0 equal to b squared root 2 minus 24b minus 128 root 2. Multiply through by root 2. Here b squared root 2 times root 2 is b squared times 2, which is 2b. 24b times root 2 is 24 root 2b. Minus 128 root 2 times root 2 is minus 128 times 2, which is minus 156. So 2b squared minus 24 root 2b minus 256 equal to 0. Divide through by 2. Here 2 cancels 2. While here 24 divided by 2 is 12. And here 256 divided by 2 is 128. So b squared minus 12 root 2b minus 128 equal to 0. This is a quadratic equation. If you solve using the quadratic equation formula, you'll get b equal to 16 root 2 or b equal to minus 4 root 2. B is the length of this side. It cannot be a negative number, so we don't want this. Therefore, b equal to 16 root 2. Substitute here. Now area of blue equal to 8 times 16 root 2 times root 2, which is 256. So the area of this blue triangle which you are asked to calculate is 256. Thank you for watching. Please subscribe, like, share and comment, and also turn on notifications. Thank you.